Alright, this is page 8 of your notes, and we're going to talk more about functions and different properties or things that we can pull out of functions. So, independent variable is your input of the function, most commonly called your x value. So independent is x. Dependent variable is the output of a function, which is usually your y, and we're going to be talking about f of x as well. So this is just a organizer here that shows you that x goes to y. X is also input, independent, and domain, which is what we're going to start talking about today. And then y is f of x, or your output, dependent, and range. And so one way to help you remember all of these is if you were to draw a little XY graph and you would label it. This is your X, this is your Y, this is your input, output, domain, range. Okay. And the more times you draw that, the more times you're going to remember where everything falls on the graph. So everything for x is over here, everything for y is the vertical part. Okay. When we're talking about independent-dependent problems, usually it's written like the dependent variable is a function of the independent variable. So we say y is a function of x because y is dependent and x is independent. Or sometimes we'll say y depends on x. And we'll probably get into more of that later on. So there's a lot of vocabulary on this front page. Discrete graph is a graph where the data points are not connected. For this type of graph, domain and range are written as a list of numbers, which is what we're going to start doing today, domain and range. So if I have a graph, and I put x and y, basically a discrete graph is just kind of like a scatter plot. It's disconnected. Okay, the points are disconnected. Alright, and then a continuous graph is a graph where the data points are connected. And for this type of graph, domain and range are written using inequality symbols, which we will be talking a lot more about next week. So to graph it, we have x and y. And continuous just means it looks something like that, right? All of the points on the graph are connected. Alright, so our notes here are specifically on the back about domain and range. The set of all inputs for a function is known as the domain. And today I'm going to highlight all of my x values in one color. So x is pink today. X is my domain. And a domain is just a list or a set of possible answers. Okay? So, possible answers for x. And then the set of all outputs is your y, and that's your range. I might need to get a different highlighter here. And the range is just also a list of possible y values for a problem. So we're going to do a couple examples here. For each function below, identify the domain and range. So on this first one, I want us to rewrite this as x, or add it to the top. That mapping, okay, so A is a mapping. Oops. And the domain is all of your x values. So domain is all of these values here. And we write it as a list. So either do the squiggle brackets, or you can do square brackets. But you have to put brackets. If you put parentheses, then you're writing an order pair, or you're multiplying, which we're not doing here. We're writing a list of numbers. And we usually write them in numerical order, smallest to largest. And the range is a list of all your y values. So that's here. And I have -3 and 4, and that's it. So letter B, I have a table is my representation. And remember, the input are the x values. That's your domain. So my input here, my domain here, is 3, 5, and 7. And then my range is my output, which is -2, because we're going to put them in order from smallest to largest, -2, 1, and 6. And listing your domain and range for a discrete function is as easy as just writing out the numbers. Letter C is a list of ordered pairs. So again, we're going back to all 4 representations. And the domain is all of your x values. So -7, 9, -6. And we're going to write them in numerical order. So -7, -6, +9. And then range is all of your y values. So I have 0, -3, and 2.5. And in order, it's -3, 0, 2.5. Okay. On letter D, we have a graph. But before we can list domain and range, we have to first label the coordinate, which just means list the order pair that represents that point. So remember, when we write order pairs, we start at 0 and we do the x value first. So I'm going to go right 1, 2, and I'm going to go up 1, 2, 3, 4. So this point is right 2, up 4. So we always do x and then y. This next point is 1, 2, 3, up 1, so 3, 1. And then this last point, and when I plot points, it's kind of like you have to walk to the elevator before you can go up or down. So I'm going to walk 1, 2, 3, 4, 5, and then I'm going to go up 1, 2, 3. So this is 5, 3. And again, your domain are all of the x values, and now that I have them written out, it's a lot easier to see what the domain is. So it's 2, 3, 5. And then my range is all of the y values, 1, 3, 4. And what type of graph is example D? All of the points are disconnected, so this is called a discrete graph.